Hey guys, today we are going to do section 1.2, functions. A relation is anything that assigns elements from one set to another set. The special type of a relation is called a function because it assigns any element from the first set with exactly one thing in the second set. So a function, input, output. Domain is the inputs, range is the output. So anything in the domain can only go to one thing in the range. So if you plug in something, if your function, quote unquote, works, meaning your relation works and it's a function, every single person who plugs in the same input should get only the same answer, the output. So let's look at an example here. Time of day, 1, 2, 3, 4, 5, and 6. That is your input, that is your domain, and each of those times have a specific temperature. Notice, at 4 o'clock and at 3 o'clock, it is 15 degrees Celsius. You are allowed to have 2 or more elements in your input going to the same output. But notice, each of these inputs only have one line coming out of them. That is what a function is. You're only allowed to have one line coming out of each input. So your domain are these 6 elements, and your range only has 5 because 15 has 2 inputs going to that output, and that is allowed. So in ordered pair notation here, this down here are all 6 of your ordered pairs of your function. Your input is the time of day, your output is the temperature at that time. Notice all the x values are different, and here is where we have a repeat in your y values, and that is allowed. So if you want to put a star here, no x's are repeated. All right, write down these characteristics of a function. Here is 2 different representations of a function. We're going to see if they are functions or not. On the left, that is an input-output table. On the right, that is a graph. Your input-output table, if we were to write these as ordered pairs, 2, 11, x, y. Take a look here and think about if this is a function or not in part A. If you notice, there are 2 input outputs here that have 2 as the input. There's a repeated x. So because of that, this is not a function. On the right-hand side, graphically, if you look at each point, you could rewrite each point as its ordered pair. So this one up here is -2, 3. This one is -1, 0, 0, -1, 1, 0, and 2, 3. All we care about is a repeat in your x values. In this case, we have -2, -1, 0, 1, and 2, so there are no repeats in x values. So this is, yes, this is a function. And you might sometimes see me write fn for function. In order to determine whether a graph is a function, it is known as the vertical line test. If I were to make a vertical line right now, let's change its color, why not? When I move this, it can only hit one point at a time. If it passes through 2, then that means there is a repeated x, a repeated input, so that would not be a function. In this case, we have 5 different points, all different x values, so this one is a function. Function notation. We have learned y equal to. In our 1.1, we learned about lines. and we learned about slope-intercept form, y equals mx plus b. If we're ever graphing something on our calculator has set in stone y equals. That's still the case. However, in math analysis and in later classes in calculus, what's going to happen is you might be dealing with multiple functions at a time. So instead of making every single one of them y, there is a new notation that allows you to name each function separately. So looking at our equation up top here, y equals 1 minus x squared. Our input is x, and our output is y, or our output is the entire expression 1 minus x squared. Our new function, our new way of rating our function, instead of rating y, it is going to be f of x equals whatever our function is. So instead of rating y equals, we use the notation f of x. This means x is our input variable and f of x is our name of our function, and that takes the place of y. All right, so for here, our f of x is just exactly what we had a minute ago. F of x equals 1 minus x squared. For x equals -1, we are finding the value of the function f when x is -1. So we are substituting -1 in for x, and we write the notation this way: f of -1 equals 1 minus the x value squared. So 1 minus -1 squared is 1, so 0. So f of -1 equals 0. This notation is nice because if we are trying to find the value of our function at 6 different locations, 6 different instances, this notation is nice because just by looking at this, I know that the input variable is -1 and our output at -1 is 0. So the point on our function would be -1, 0. Go ahead and take a minute and solve for f of x when x equals 0. If you said 1, you are correct. So this f of 0 equals 1. The ordered pair, if you were to graph it, would be 0, 1. Although f is convenient name, there could be other names, and also x is very convenient for being an independent variable, but sometimes you might be talking about time. So our original function f of x equals x squared minus 4x plus 7. If we're dealing with time, in some textbooks when you're dealing with time, they would use the input variable of t instead. So notice these x's were just replaced with t's. And also, if you're dealing with time in terms of seconds, s could be used. And also, if you are dealing with 2 different equations and f is already taken up, g is also a different way of writing a function. So if you have 3 functions, you may see 3 functions on the same graph. One's called f of x, one's called g of x, one's called r of x. All of these are defining the same function right now. These 2 just here replace x with s. All right, so here we have a function g of x equals -x squared plus 4x plus 1. I would like you to take a few minutes and evaluate that function for the input 2, the input t, and the input x plus 2. Be sure to simplify your expression as much as possible. For b and c, your answer will have variables in it, whereas a is going to, your output is going to be a specific number. All right, for part A, g of 2, when you plug in 2, notice whenever I'm replacing x and substituting in a value, I put parentheses around it, even if it's a positive number. So g of 2 equals 5. Part B, g of t. You are only changing your variable of x to t. I put parentheses around just to get into a habit here. So g of t would be -t squared plus 4t plus 1. Before you solved g of x plus 2, I figured I would just come down here and show you. G of x plus 2 is what you are substituting in for x, which is weird. You are substituting in an expression that involves x into something that has x. So whenever you see the x in your equation up here, you are plugging in x plus 2. So you have, all that you have to do now is simplify this right here using FOIL and distributive property and combining like terms. So go ahead and do that. Take a minute here and check my work. For g of x plus 2, g of x plus 2 would simplify to negative x squared plus 5. Domain of functions, your x values, your input, you can be given them explicitly saying x is greater than 2, or look based on the expression given for the function. There are some mathematical rules that may create something called domain restrictions. So you may need to understand that your domain might be the set of all real numbers except for a few instances, or it only might be a partial piece of your number line for x. So think about what are some rules in algebra that create domain restrictions when you are given a variable expression. Think about things that you cannot do in math. So come up with something where you would hear x cannot be equal to blank because of a rule. Think about that for a minute. If you said either of these things, you cannot divide by 0, or you cannot take the square root of a negative number, you are correct. If not, don't worry. I just wanted to see what you guys came up with for those rules. All right, so determine the domain of these two functions here. The first one up top, we have a variable in the bottom, and on the bottom example, we have a square root of a variable. So when you are given a function where a variable is on the bottom, you set your denominator equal to 0 and you find what x values would make the denominator equal to 0, and those are your domain restrictions. So x squared minus 4, we are setting that equal to 0, and we are going to solve that. That is a difference of squares, so x plus 2, x minus 2. So what values of x would make the denominator equal to 0? If you said negative 2 and positive 2, you are correct. So over here, your domain would be all real numbers except when x equals negative 2 and positive 2. And my handwriting is atrocious here. My apologies. All real numbers except negative 2 and positive 2. For the bottom example, f of x equals the square root of x. You cannot take the square root of a negative number because that would be an imaginary number. So for the square root ones, you set the entire radicand, the thing under the house inside the square root. Your domain will be that expression greater than or equal to 0. If you had x plus 7, you would need to solve that inequality x plus 7 is greater than or equal to 0. You can take the square root of 0. So for this one, your domain, since there's nothing we need to simplify, your domain would be x is greater than or equal to 0. Take a few minutes here. This one here is a function with just specific 5 points. This one here is a quadratic, and this one here is the rational function with a variable on the bottom. Go ahead and take a few minutes and solve what the domain would be for each of these 3 functions. All right, here, part A, your domain is the set of all your inputs, your x values. So this is how you would write it in roster method here, negative 3, negative 1, 0, 2, and 4. That would be your domain, those specific 5 values. Part B, that one was a little tricky because we were dealing with the domain restrictions. Here we have a polynomial, a quadratic, x squared. You are allowed to plug in positive numbers for x, negative numbers, and also 0. So there is no restriction. So part B, the answer is all real numbers. Part C looks like one of our previous examples. Check for your domain restriction the value of x that makes your denominator equal to 0. So h of x, the domain is all real numbers except for when x is negative 5. This is all I have for section 1.2 for right now. Let me know if you guys have any questions. Have a great weekend or a great week, and I will see you next class. Thanks, guys.